Hello everyone. Let us understand what is distance vector routing or distance vector algorithm in computer networks. Consider this as a topology, and I have A, B, C, D, E as the nodes, 5 nodes, and these are the cost associated with the nodes from each other. So from A to B, if the cost is 5, A to D, the cost is 3, and so on for the rest. So it is an interconnected network where I am considering A as the root node. First of all, let us initialize the matrix or construct a table which is personal to every other node. So let us call this table as the rudimentary table, where the cost from A to every neighboring nodes only are mentioned here. So from A to A, the cost is 0. A to B, the cost is 5. A to C, the cost is 2. A to D, the cost is 3, and A to E, it is not directly connected, so I will put it as infinity. So construct these kind of rudimentary table for all the other nodes, so that we have rudimentary table for every participating nodes. Next, in the second step, we share the table information with the neighbors. So now A has got its own table from the previous step, so it will be sharing with C, and C will be sharing with A. So let us look into what happens when we share the rudimentary table and compare and try to update. So this will be the third step, where we try to have a better understanding, that is whether I can consider, if I am going from A to B, if A to B has got a other route which is better than the direct A to B. So in this case, 4 plus 2, 6 is not less than 5, which is direct connection, but it might be when you are considering so many other nodes or any other possible combinations. So let us compare. This is the matrix from A which is received from C. So if C has got a rudimentary table which is going to be shared to A, so this is what we are getting here. So from C to A is 2, C to B is 4, C to B is 4, C to E is 4, C to E is 4, and C to D is not directly connected. That is why C's rudimentary table doesn't have D's value currently. So this is the cost associated with the C to A in the very beginning. That is called the rudimentary table. Now this is the A's old table, as discussed. What we have, A to E is not available, rest of the cases are all available, so that is what the A's old table. Now consider A's modified table, that is we are considering A to C, so I will add this distance 2 with C's table. So from A to C I have a distance of 2, so I will add 2 for all the cases. So 4 plus 2 is 6, 2 plus 2 is 4, 0 plus 2 is 2, infinity plus 2 is infinity, 4 plus 2 is 6. So this will be my A's changed table or the modified table. I'm going to compare this table and A's old table. So let us find which is better. So if 0 and 4 are compared, so I will consider the 0th value, because the main intention here is extracting the minimum value. So we have to travel a minimum distance when it comes to cost. So 6 and 5 is 5, 2 and 2 is 2, infinity and 3 is infinity, 3, and 6 as infinity is 6. So we have all values except that we do not have any infinity values. That means all the tables are reachable right now from A. So consider this case where I have the source node in orange and destination in green. So K is my intermediate node. So is it possible that I can find source to destination via any other node? So this will be my via node. So K. So T of ij, it is I to j. Can it be replaced by I to k and k to j? So D of ik and T of kj. So please remember this, so that we will explain the same thing during the programming. So if T of ij, that is this one, this path is greater than this and this added together. So if I am reaching from here to here, I am having a better option, so I will replace that. Otherwise, I'll keep this as the shortest node. So in case T of ij is greater than d of ik plus t of kj, that is this sum, then I am replacing t of ij with the sum of this, otherwise I will keep as it is. Okay, so once I am done with that, I will have this kind of table. So my rudimentary table in the initialization step had infinities, and now it doesn't have infinity. If you are able to understand, from a to a 0, a to b is 5, a to c is 2, a to d is 3, and a to e has been replaced by infinity to 6, right? So from it has been replaced by 6 before it was infinity. So this is the way we are going to travel, and this is mentioned here. So this is the path which we are going to consider. So same happens for all other nodes. We are going to see what the program looks like. So we are having the main program, and D is the matrix, two-dimensional matrix, which refers to the cost matrix, how much cost associated with every node. T will be my distance vector, and A will be my intermediate node. So D, K, and this is my intermediate node. So loop variables, I have taken I, j, n, and k, and count. Let us understand what count is later on. So enter the number of nodes. We have a, b, c, d, e. So we have 5 nodes here. Enter the cost matrix, initial cost matrix. So for I to 5, that is 1 to 5. So consider all the nodes in we are going to have a two-dimensional matrix. That is why I have two for loops, one inside the other, nested for loops. So in scanning, while we are going to take the cost matrix, that is d cost matrix I to j, initially we are going to scan. So we are also going to mention that from that node to that node itself, the cost will be 0. That is, you are there in the node number 1, so you have to travel to node number 1 again. The distance you have to travel is 0, and t of ij is equal to d of ij. So this means we are going to associate a cost matrix with the distance vector. So right now my cost matrix is itself the distance vector. So we are going to do for all the 5 cross 5 in our case. And finally we are going to equate j, which is the via node or the intermediate node, and a of ij, currently my via node will be a of ij, that is j itself. In the second step, we are going to run this do while loop until the cost is not equal to 0. Okay, I will explain what cost is, count is, and before that, let us understand what is happening inside the loop. So initially, consider a count which is equated to 0. So for one, I is equal to 1, I less than n, that is for 5 different nodes, nested for loop. For k is equal to 1, so we have this part we are going to consider. Again, I'm going to execute this part in the nested for loop. So for I, j, k, all the values from 1 to n. So if t of t of ij is greater than d of ik plus t of kj, that is traveling from I to j has got a better value if I am traveling via k, then I am going to replace it. Otherwise, I am going to keep it as it is. That keeping as it is doesn't have to be shown in the code. So t a of ij will be my via node, new via node. So once I have made any change, I will increase the count. So I will increment the count. So until any change is not happening, I am going to run this loop. So update the routing table t of ij, which is my routing table for I. K becomes the next node, that is the via node. Increment the count so that the count incremented shows I have made some changes in the routing table. So until then, you keep on running this loop. Finally, we have I is equal to 1, I less than or equal to n, I plus plus. So for router, for the same cases, we are going to print the matrix. So how is it going to be? So printf, uh, from that particular node to this node, what is the distance? So from j to a of ij, that is from the node via node to the intermediate node, this is going to be the cost. So print all the values so that you will have the new distance vector as a table. So currently we are going to have from A to B as 5 instead of 6, and in case I can travel 5 plus 3 8, and this is 4, I can travel via from A to C to B to E if I have to travel, and if that is the cost which is lesser than the any other straighter distance, that will be displayed. So this will be the distance vector routing. Thank you so much.